Good evening, good Saturday evening, dear colleagues. My name is Hugo van Wever. I'm the past president of APAPARI, and I will be sharing this session with my colleague, Professor Fujisawa. Welcome to this APAPARI session. It is now my pleasure and honor to introduce Professor Takumi Takizawa, who is from Gunma University, Japan, and who is also a very active member in APAPARI and a board member. Professor Takizawa will talk to us about pollution and childhood asthma. Go ahead, Professor Takizawa.
Hey, thank you very much, Professor Hugo, for kind introduction. And I would like to thank organizing committee for giving me an opportunity to give a talk today. So the topic of my talk is the air pollution and childhood asthma in Asia. I have no conflicts of interest to disclose today. So one of the major causes of air pollution is chemical and physical pollutant, particulate matter, PM2.5, which is the particle whose aerodynamic diameter equal to or less than 2.5 micrometers. Or another pollutants is chemical pollutants such as sulfur dioxide, nitrogen dioxide, and ozone. So WHO says the air pollution is the leading environmental risk factor globally, and it estimates 7 million deaths are attributable to the ambient and household air pollution. And the air pollution causes acute chronic lung diseases, ischemic heart diseases, lung cancer, stroke, type 2 diabetes, neonatal mortality from low birth weight. So one of the most famous asthma incident related to air pollution is Yokkaichi asthma in Japan during 1960s. So it took place in Yokkaichi city, located in Mie Prefecture, where today's another chairman, Professor Fujisawa, is working. So that in 1965, oil combinate was built in Shiohama in Yokkaichi City. And then 5 years later, the people noticed that abnormally high incidence of asthma in the district. As you can see here, the asthma incidence in this district is much higher than other places, other neighboring places. And then people noticed that when you look at the sulfur dioxide concentration, the concentration is well correlated with the yearly accumulated prevalence asthma. This is 60 years ago, but the very, very famous incident in Japan. Okay, let's look at the pollutant concentrations, the global pollutant concentrations. As you can see here, all these pollutant concentrations are high in Asia. So PM2.5 is high, very high in China and India. The ozone is much more evenly distributed, but still you can see the high concentration in Asia. And the nitrogen dioxide, not just in China and India, but also the Japan and Korea and Indonesia. So that all these pollutants are very condensed in Asia. Okay, so I would like to focus on the particulate matter 2.5, particulate matter 2.5 after this. Why is it? That it is known to be the most harmful air pollutants to human health. And the sources vehicles, power generation, industrial activity, and biomass burning. So WHO recommend the concentration of PM2.5 should be below 10 microgram per cubic meters. So once it exceeds that recommended concentration, it causes a variety of harmful, to say that, health-related disorders. And PM2.5 is very tiny. Since it's tiny, it can be easily inhaled into the lung, and it reaches alveoli, and then can penetrate into bloodstream, can cause systemic health disorders. So this slide shows the relationship between the PM2.5 concentration and mortality. As you can see here, a very good linear relationship between the PM2.5 concentration and mortality. So that it is very serious problem for our health. So in terms of lung, it's also affected different pathological pathways. So it can cause oxidative stress, and it can activate neutrophils and eosinophils. And it also causes imbalance between Th1 and Th2 cells. It actually enhances Th2 types of response, which is related to asthma. Okay, let's go back to the global map of PM2.5. This is estimated to be PM2.5 exposure. This is weighted by population. Still, you can see the very high exposure levels in Asia. So the childhood exposure to PM2.5 is known to contribute to asthma development. This is a meta-analysis. As you can see here, there is a significant association between a PM2.5 increase by 1 microgram cubic meters and asthma at any age. So the odds ratio is 1.003. This is not very high, but it's still significant. And this study shows that the compliance with WHO guidelines, PM2.5 concentration, which is below 10 microgram, could prevent 11% incident cases of childhood asthma. So the PM2.5 is related to asthma development. But not just the exposure during childhood, the prenatal exposure to PM1 in this case increases risk of asthma development. And this is shown by the study in Chinese preschool children. They basically investigate around 6,000 preschool children aged 3 to 5 years in central China. And what they found is that the exposure during pregnancy to PM1 is causes very high risk for the asthma development during childhood. Specifically, during first trimester exposure shows the higher risks. So this study comes from Taiwan, that they investigated 100,000, 200,000 children in Taichung City in Taiwan. Then what they found is PM2.5 exposure during pregnancy, and both pregnancy and infancy increases childhood asthma. As you can see here, the prenatal exposure and postnatal period, specifically until the first year of life, is a risk for the development of asthma. The PM2.5 increase also affects not just asthma development, but asthma exacerbation in children. So a number of studies have done have been done to examine this, and this is a meta-analysis of 26 studies. The study shows basically the relative risk for ED visit and hospitalization by increment of 10 microgram in PM 2.5 causes a risk, a relative risk for about 1.05. Still, it's not very high, but it's significant. When you look at the category-specific results, the age less than 5 years old shows higher risks, and the warm seasons shows higher risks. And interestingly, the North America and Europe shows higher risks than the Chinese population. So this suggests that the Asian ethnicity is less susceptible to PM 2.5. Okay. So this study from Taiwan shows that the changes in the relationship between childhood asthma and the ambient air pollution in Taiwan. They basically investigated the PM 2.5 concentrations and the current asthma prevalence in 2011. And 5 years later, they did the same thing, and they found that the PM 2.5 concentration was decreased in 5 years, but the current asthma prevalence was actually increased. And when you look at the odds ratio, by IQR increase in PM 2.5, actually the different. The 2011 shows the higher odds ratio than 2016. So the risks brought by the PM 2.5 can change. Okay, let's go back to the Yokkaichi asthma. Actually, the Yokkaichi asthma subsided swiftly after low regulation of sulfur oxide exhaust. So as you can see here, these orange bars number of patients, and the blue line shows the concentration of sulfur dioxide. So once the sulfur dioxide had started decreasing, the number of patients was also decreased. So this graph clearly shows that the most efficient countermeasure against the air pollution is the regulate the exhaust. Okay, so that this slide shows the kind of different types of countermeasures. So this is a study from Japan, is nationwide investigating group, Japan Environment and Children's Group. So they basically investigated 1,500 infants, and then tried to create concentration of PM 2.5 and desert dust, which comes from the Chinese desert, and then then asked the nose and eye and respiratory allergic symptoms to their mothers on web-based questionnaires. What they found is PM 2.5 is not per se is not the risks for the allergic symptoms, but when you add it, the Asian dust, desert dust, it can be a risk for the allergic symptoms. And when you look at the children who experienced wheezes before this questionnaire, the risk is also high. And they also investigated the And when they stayed outside more than 3 hours, the risk becomes higher. And then they opened windows, the risk is higher. And they also if they took the leukotriene receptor antagonist, risk is lower. So they basically conclude that reducing the time outdoors and regular use of leukotriene antagonist and closing window and receive particulate forecast can be a countermeasure against the air pollution. Okay, so let's go to the end of the slide. This is a summary of the slide. So the ambient pollution Asia is heavy. The PM 2.5 exposure in utero during early childhood increases asthma development in children. The impact of PM 2.5 on childhood asthma might not be enormous, especially in Asian population, but still significant. And I know it's difficult, but PM 2.5 can be reduced by regulation. So I think we should be concerned about this problem, and maybe we should give the warning to the policymakers. Okay, thank you very much.
Thank you, thank you, Professor Takizawa, for a nice overview on pollution and the role in asthma. I give now the chair to my friend, Professor Fujisawa.
Okay, thank you, Hugo. My name is Takao Fujisawa from Japan. So I'd like to invite the next speaker, Professor Elizabeth Tam. She is from National University of Singapore. And she's going to talk about childhood allergies. What have we learned from gastro cohort? So very important cohort. Please start your lecture.
Good evening, everybody. And thank you very much to our chairs for the kind introduction. So I'm very honored to be the last speaker of a very exciting day of scientific lectures. The topic that I'm speaking on today is on childhood allergies. What have we learned from the gastro cohort? I have no relevant conflicts of interest to declare. So I'd first like to introduce you to GASTO. It stands for the Growing Up in Singapore Towards Healthy Outcomes cohort. It is a large population-based birth cohort study where we recruited over 1,200 mothers from the year 2009. And these were recruited from 3 Asian ethnic groups, the Chinese, Malay, and Indian. And we had very close longitudinal follow-up, and more than 800 families are still on active follow-up with a retention rate of about 80%. The children are now between 10 and 12 years of age. So I will share with you today the findings that we have gathered from our extensive follow-up of these children in the areas of atopic dermatitis, followed by childhood rhinitis, and then food allergy in Singapore as compared to our counterparts in Australia. So this is a paper that we have just published earlier this year, looking at atopic dermatitis trajectories to 8 years in the gastro cohort. So this was done from birth all the way up to 8 years of age, and we used an unsupervised machine learning approach called expectation maximization method with K-fold validation. The main outcome we looked at was doctor diagnosed AD over 12 time points from birth to 8 years, as you can see from the diagram above. We looked at its association of each trajectory with risk factors in the antenatal and postnatal periods, as well as its associations with allergic comorbidities, wheezing, allergic rhinitis, as well as food allergy and sensitization. So these are the trajectories that we have found, and I'll bring you through them one by one. In red, you can see this trajectory that spikes early in life in the first year, and then it slowly comes down and disappears towards the 5th to 6th year of life and remains low thereafter. So we term this trajectory as the early onset transient pattern. And then in the green lines, you can see one that rises a little later than the early onset transient, but this one remains high and even higher so. Comes down a little bit after 6 years, but still remains higher than the rest of the trajectories. And we term this the early onset persistent group. And then there's another group in blue, which started much later than all the rest, and you can see that it comes to plateau somewhere in the middle of the first two trajectories. And there is another group which we termed as the reference group. It was all the way, the probability of atopic dermatitis remained low. So these were the trajectories that we found in the Asian children in this cohort. Then we next looked at their associations with risk factors as well as allergic comorbidities. The risk factors in the early onset transient AD cohort trajectory was that of being a male gender, a family history of atopy, breastfeeding, and being of Indian ethnicity was protective. Allergic comorbidities wise, there was associations with wheezing at 36 months, 16 months, as well as at 8 years. So we notice a strong link to non-modifiable factors in this cohort. The association with breastfeeding is likely to be related to reverse causation, as been shown in several other papers in the literature as well, where the presence of AD in early life might actually cause a change in breastfeeding behavior, such as the mother breastfeeding for a longer time because the child has already developed AD. However, the association with wheezing is quite interesting, and it begs one to wonder whether or not the mild and transient AD that is experienced by this group, that it disappears later on but is insufficient to trigger severe and persistent skin inflammation at the start, but is still capable of inducing some systemic immune priming or airway inflammation later in life. The early onset persistent AD group had risk factors with associated with antibiotic use during pregnancy and labor, household smoking, as well as childcare attendance in the first year of life. It was also strongly linked to food sensitization. So here in the first section on risk factors, we note that there might be a role of the microbiome where it might be modifying the stool, the gut, or the systemic microbiome to affect AD onset and persistence. And the strong links to food sensitization might be also related to epicutaneous sensitization through the impaired skin barrier. So this leads me to the next point about the dual allergen exposure hypothesis, which I want to just introduce and talk about a little bit here. So in food allergy, there is always a balance between epicutaneous sensitization and oral tolerance in early life. And this is a nice diagram that was shared first by Gideon Lack's group. So sensitization occurs through the skin barrier defect that happens in atopic dermatitis in early life. And this exposes the innate immunity cells, such as dendritic cells in the deeper dermal layers, to environmental allergens such as food allergens, which are ubiquitous in our environment. And this then leads on to allergen sensitization through activation of the Th2 pathway and cytokines such as IL-4, 5, and 13 production. And at the same time, with GI tolerance, such as in weaning and introduction of solid and allergenic foods, this happens through the Th1 pathway through production of IL-10, TGF-beta, and interferon gamma, and this will induce tolerance. So early introduction of allergenic foods has been thought to promote tolerance, whereas delayed introduction of allergenic foods might promote food allergy. So in the late onset persistent AD group, we found that house dust mite sensitization in early life was a strong comorbid factor. The family history of atopy was a major player here, and there were strong associations with house dust mite sensitization at 3, 5, and 8 years, and also with other allergic disorders later on in life. So this brings us to wonder whether or not the high environmental dust mite load, which is present in areas like Singapore, which are hot, humid, tropical countries, and the presence of an impaired skin barrier might actually induce house dust mite sensitizations and systemic inflammation. And this would be the pathway leading to the development of allergic airway disorders in later life. I'll now move on to childhood rhinitis. And similarly, we looked at trajectories of early onset rhinitis in this cohort. Using a similar machine learning method called the group-based trajectory modeling, we found that in this cohort, there were also 3 different trajectories of allergic rhinitis. The first trajectory that I'll describe here is the early onset transient rhinitis, which is the line in green. So these children had rhinitis symptoms, which were quite prolonged, more than 2 weeks of duration, which is less likely to be infectious. And this declined over time, and these remained low after a while. And there was another group, which we termed as the late onset rhinitis group. It started off low, but then it peaked somewhere around the 2nd to 3rd year of life, and then this declined gradually. And there was another group that started low as well, but this group had gradually increasing prevalence and persistence of rhinitis symptoms. And this remained high and remained all the way high all the way to 8 years of age. So the early onset transient rhinitis group, we found that they had strong associations with genetic non-modifiable factors like ethnicity, as well as environmental modifiable risk factors such as childcare attendance and siblings. There was also an association with wheezing and eczema from early life, and this might be consistent with the Dohart or developmental origins of health and disease hypothesis. The late onset transient rhinitis group had no associations with any atopic features, but there were strong associations with environmental factors such as maternal tobacco smoke exposure, higher maternal education levels, and we noticed that there was a concomitant onset of rhinitis and wheeze, and this leads one to think about whether this could be actually due to recurrent viral infections in early childhood. And there were strong associations with wheezing and in later childhood as well. In the persistent rhinitis group, there was a strong familial or genetic predisposition, so such as a family history as well as male gender. And we noticed the strong links with atopic dermatitis, allergen sensitization, and allergic rhinitis and asthma. So this kind of follows the atopic march, but it's not the classical kind because the rhinitis onset would begin in early life alongside eczema, but this would be the highest risk phenotype, which leads to the persistent rhinitis and true allergic rhinitis in later childhood. So what we've learned from this study is that modifiable risk factors could be addressed in early life to ameliorate progression of rhinitis to other allergic comorbidities that would include antenatal smoking exposure, childcare attendance, socioeconomic status, as well as viral infections through, for example, vaccination or hygiene practices. We could also recognize the high-risk phenotypes early in childhood and would follow these patients up longer to prevent the progression to other allergic comorbidities. Next, I'll move on to food allergy. And this is a paper we published a few years ago looking at food allergy in the gastro cohort. And I would just like to remind everyone that gastro is a general population, so it's not selected for high risk of atopy. We looked at food allergy prevalence and timing of allergenic food introduction from birth all the way to 4 years in this cohort. So looking at timing of weaning or solid food introduction, 2.2% of the children were introduced to solid foods before 4 months of age, 31% were introduced between 4 and 6 months of age, and the majority were introduced to solid foods only after 6 months of age. Looking at the timing of each individual solid allergenic food introduction, unsurprisingly, cow's milk introduction was mostly before 4 months of age, and the majority of them had this around birth, and this is common when breastfeeding is transiting to stability, and most of the infants would have some formula cow's milk as supplementation. For egg introduction, you look at the second 2 sections of bar graphs in the middle. About 30 to 50% of them had egg white and egg yolk introduced only after 10 months of age, which are the purple bars. And for peanut, look at the tall purple bar on the right side. More than 80% of them were introduced to peanut only after 10 months of age. And at 36 months, almost 5% of them had never tasted peanut before. The mean age of introduction in this cohort was at 19 months of age. And in the last segment, shellfish, 84% of the infants had been unexposed even by 1 year of age. And we don't have data beyond 12 months, but it's needless to say that shellfish and peanut introduction was significantly delayed in our cohort. Next, we looked at the food allergy prevalence, and this was defined as a convincing history of an IgE type reaction and with a positive skin prick test at the time points which was done. So this was month 18 and month 36. So you can see here that the highest prevalence of food allergy was at 12 months, and this was close to 3%, but it gradually dropped thereafter. Egg allergy, which is the bars in yellow, was most predominant in those younger than 2 years of age. And peanut allergy, if you look here at the brown bars, was not a common allergen in Singapore at all, despite the delayed introduction, and this prevalence remained below 0.3% throughout. And this was not due to unexposure, because one may wonder, is this because no peanut was introduced and therefore you could not pick up peanut allergy? We moved on to look at this all the way to year 8. And peanut allergy prevalence remained low throughout early childhood all the way to year 8. The mean age of introduction, if I mentioned earlier, was 19 months, and yet all the way to year 8, the prevalence remained even lower than it was in early life, in childhood. And we noticed also a predominance to shellfish allergy, which began a little later, around 3 to 4 years of age. But by the time they were 7 or 8 years of age, this was the #1 allergen in this cohort. So the risk factors for food allergy in Singapore were early onset eczema, especially that of increased severity. There was also a strong link with family history of atopy and cat ownership, but no associations with any other social, economic, or demographic factors. So the conclusions of this study was that delayed introduction of allergenic foods doesn't always translate to increased food allergy risk in different populations. And so the international recommendations for allergic food introduction might always be tailored to the local setting. And there's always has to be a balance between the cost effectiveness of evaluation of allergy and the need for intervention in cohorts which already have very low food allergy prevalence. So next up, we moved on to look at how food allergy was different in children of similar ethnicity living in different environments. And here we looked at Singapore versus our counterparts in Melbourne, Australia. The Health Nuts cohort looked at food allergy using a oral food challenge to egg or peanut at 14 to 18 months of age. And as I mentioned before, we use a convincing history of food allergy with a skin prick test. And interestingly, we found that the food allergy prevalence in Australia was much, much higher than that in Singapore, even though the children were of similar Asian ethnicity. Looking at demographic differences, there were not much differences in terms of delivery mode, maternal education. The Singaporeans had larger families. Mothers in Australia tended to eat more allergenic foods during pregnancy compared to Singaporean mothers. And Singaporean mothers had higher household tobacco smoke exposure. Looking at timing of introduction of solid foods, the Singaporean children were weaned a little later, delayed peanut and egg introduction, were more formula fed, and had shorter breastfeeding durations. So interestingly, the main difference was that of prevalence of early onset eczema. So the pink segments in the pie chart here show the early onset eczema, and in Australia, 30% of these Asians had early onset eczema, and 1/3 of them had food allergy. This was compared to Singapore, where only 8.4% had early onset eczema, and only 5.7% of them had food allergy. So after we adjusted for various confounders, we found that eczema in early onset, less than 6 months of age, remained a major morbidity or risk factor for food allergy, but not so much in Singapore. And there were no other differences in other risk factors between the two cohorts. So in summary, early onset eczema of increased severity was likely the main driving factor for increased food allergy in Australian Asians. There wasn't any other environmental exposures that we could measure responsible for the differences. However, there were other unmeasured environmental exposures, such as maybe UV exposure, temperature, humidity, vaccination practices, or dietary factors, which may also account for this, but we were unable to assess this in our cohort. So this is some preliminary data that is still in the works at the moment, but we are going to look at other comorbidities, and this time we will include the Health Nuts Asians alongside the Health Nuts Caucasians, as well as Gastro-Asians. And if you can see here, the Health Nuts Asians, which are the orange bars, are again having the highest prevalence of other allergic comorbidities besides just eczema and food allergy. They have higher rates of allergic rhinitis and asthma, as well as sensitization to any of the environmental allergens. So in conclusion, early life environment plays a key role in allergy pathogenesis. Understanding the allergic endophenotypes in each population will guide prevention and intervention strategies. And there's an urgent need for international allergy consortiums with aligned measures which will be able to help us elucidate gene-environment interactions with allergy pathogenesis. And with that, I'd like to thank the Gastro and Health Nut staff, as well as the team which has put all this work together. And thank you very much for your time. I'll be happy to take any questions. Thank you.
Well, thank you very much for your very nice lecture. So Gastro cohort now has been producing a very valuable, lot of data and very interesting. Thank you very much. So we'd like to move on to the Q&A session. So we have quite a few questions. So I'd like to start from the questions to Agnes. First question is here. You mentioned about poor asthma control in Asia. What are the risk factors for poor control?
Thank you, Professor Fujisawa. So from my opinion, there are three major factors that are associated with the poor asthma control, in particular in the Asia-Pacific region. The first that I can think of is, in my experience, especially with the Chinese, the perception of asthma is a major problem. A lot of the Chinese, they are very reluctant to be labeled as asthmatic patients. They rather call themselves having hyperactive airway. It's because they have a steroid phobic mindset. They're very reluctant to take steroid for a long term because they perceive that it may bring about an impact to their growth, but it was not a right way of thinking. So the perception needs to be changed. Their mindset needs to be changed. And another important thing I would say is the technique that they are whether we have enough time to educate these parents on the proper way to use the inhaler. And this is a common problem, especially if, for example, in mainland China, as well as in Hong Kong, I'm sure some part in Japan as well, we have very short clinic time. So in a very short consultation period, we do not have adequate time to check the inhaler technique. So we need a strong teamwork to help us, the nurses, as well as other allied health, to help with educating our patients with the inhaler use. And the third point that I can think of would go back to Professor Takisawa. So it would be the tobacco smoking at home, probably the biomass fuel used at the homes of Asia Pacific region. So this is still a significant problem in this part of the world. So I think another question that I saw from the floor, I would like to address that now. We need to address the reasons underlying these poor asthma control factors in the Asia Pacific region, so that we can work together to achieve a better control. And there are a lot of these wrong perceptions out there. So thank you for this very good question. A lot to ponder upon.
Thank you very much. And next question is, what would be your top research subject in Asian children with asthma?
Thank you. So
something
apart from
urgently need to know.
Yeah, so I think apart from working towards a better asthma control, I think Asia is still an area with a lot of heterogeneity. So you can see from the prevalence study, so there are a very diverse pattern of asthma prevalence, even among the Asian regions. So for example, Japan, Korea, they seem to have a pattern of the Western world. But for a lot of other countries, especially Southeast Asian countries, they are having a prevalence similar to the developing world. So by examining the environmental determinants of these regions, by just the positioning, the urban and the rural environment, it will give us a lot of clues about the possible factors behind these diverse prevalence, and so that we can identify some of the preventive factors to help with us. So I think this would be the key questions that we want to address. Thank you.
Thank you. That's very important. So I'd like to move on to the questions to Professor Takizawa. First questions, do you think air pollution can cause asthma, or just it merely trigger that can make established asthma worse?
I think that when you look at the risk ratio, difference in risk ratio between the European countries and Asia, so I think it very depends on the ethnicity or genetic background. So that I think the susceptibility is really important. So otherwise, the asthma prevalence in China or India is much higher than the other European countries. So I think the air pollution is trigger rather than the cause of the asthma.
Okay, thank you. So next question is about PM 2.5. So is it systemic effect or local lung injury?
Okay, as far as asthma is concerned, most of the studies have been done in the local effect. So most of the studies focused on the local effects of PM.5 in terms of asthma. But I'm sure that it can penetrate in the bloodstream. It can change our immunological response. So that I think that both, but the studies almost exclusively done in the local problems. So,
okay, thank you very much. One more question. So, do you have any comments on the impact of maternal exposure to PM.5 on childhood asthma and any association with microbial dysbiosis?
So that as far as I investigated, I couldn't find the papers showing that any relationship between the microbial dysbiosis of mother and the PM2.5 exposure and asthma development. But when you look at the study from China, the prenatal exposure to PM1, actually the PM.5 exposure during first trimester shows the higher risks than the second and third trimester. So that means that I guess this means that the PM.5 influence is more systemic rather than the microbial dysbiosis. If it is caused by the microbial dysbiosis, maybe the exposure during third trimester should have the higher impact. This is what I think.
Okay, thank you very much. So, okay, I'd like to move on to questions to Professor Tam. First question is, could you give ideas on how to study epicutaneous sensitization in eczema?
Thank you for the question. I think it's a very broad topic. I think there are two aspects to this. I think there's been a lot of work on mechanisms behind how epicutaneous sensitization leads to food allergy, for example, in eczema. And this has been studied in quite a great detail. But I think the field is moving towards prevention. And so this is the area that is really lacking right now. There has been a lot of studies on skin emollients, for example, in how they prevent eczema or they may not. So recently there has been a Cochrane review, and we have also in Singapore published a systematic review and meta-analysis that was just published in Allergy, and we found that in high-risk populations, skin emollients did prevent eczema, but only in selected subgroups like high-risk population, and that application of emollients all the way up to the detection of AD or assessment of AD was actually of benefit, but not if there was an interval. So this emerging questions in the field about what group of patients would benefit from interventions such as this to prevent eczema. And not so much on just mechanisms of how it happens, but how the interventions can change the outcomes and that of food allergy. So I think that's where the field will be going towards, and we need more studies and randomized controlled trials in this area.
Thank you very much. So next question is about allergic rhinitis phenotype. In your data, late type looks a little bit different from other allergic phenotypes. How do you think about that?
Yeah, so I think this is about my study on the trajectories of allergic rhinitis. So just to recap, we had the late transient rhinitis, where the associations were actually not atopic at all. It started a little later in life and then this dissipated. So we thought that there were strong associations with, for example, environmental exposures like maternal smoking and probably viral infections. And these groups of patients had no atopic tendencies at all. And this might actually be different from those that had persistent rhinitis, but a very strong family history of atopy. And these other group, they had persistent rhinitis that didn't go away, as opposed to the late transient mutations in rhinitis. So they probably had a combination of genetic predisposition as well as an increased tendency to develop sensitization, for example, to dust mites. And this would result in systemic inflammation and lead on to allergic rhinitis and asthma. So I think there are slight differences in the two groups. Yeah.
Thank you very much. So, so it's quite a late time. So we'd like to close this session. So this session was very great, very nice. And so we had 3 excellent speakers, and they raised very important issues on epidemiology and pathogenesis and childhood allergic diseases. And we got many important inspiration from their talk. So I hope the next research will advance through their excellent lectures. Thank you very much.